It's a big question, isn't it? Does randomness truly exist, or is it just a fancy word we use when we don't know what's going on? It's something people have thought about for ages, and it touches on everything from how a coin lands to how the universe itself works. Think about it. We see things we call random all the time. A dice roll, the lottery numbers, where a lightning bolt strikes, a sudden traffic jam. You might say, oh, that was random. But what do you mean when you say that? Do you mean it just happened without any cause? Or do you mean you just couldn't predict it? That's the core of the puzzle. For a long time, most smart people believed that true randomness was just an illusion. They thought the universe was like a giant, intricate machine. Every single gear, every lever, every tiny bit of it moved in a way that was completely set in motion by what came before it. This idea is called determinism. Imagine a billiard table. You hit the cue ball. It hits another ball. That ball hits a third. Every single bounce, every spin, every angle is completely determined by the initial hit, the friction on the table, the precise angles, the weight of the balls. If you knew all of those things perfectly, you could predict exactly where every ball would end up. You wouldn't even need to watch it happen. You could just calculate it. That's how people like Isaac Newton and Pierre-Simon Laplace saw the whole universe. Newton figured out the laws of motion that explained how planets orbit, how apples fall, how everything moved. It all seemed incredibly orderly and predictable. Laplace, a French scientist, took this idea to its extreme. He imagined a super being, sometimes called Laplace's demon. This demon would know the exact position and momentum of every single particle in the universe at one moment. If it knew all that, Laplace said, it could then calculate the future of everything. And not just the future, but the past too. For this demon, nothing would be random. Everything would be perfectly predictable, like watching a movie that's already been filmed. So, when a coin flips, why does it seem random to us? Because we don't know everything. We don't know the exact force of your thumb, the precise angle of the coin, the tiny air currents in the room, the exact spin it has where it will hit your hand. All those things matter. If you could control every single one of those factors perfectly, you could make the coin land on heads every single time. Or tails. It wouldn't be random then. It would be a skill. Magicians do things like this. They make it look random, but it's not. They're just controlling things we don't see. And the weather, we call it unpredictable. Sometimes it feels random. One minute it's sunny, the next it's raining. But weather scientists believe it's not truly random, it's just incredibly complex. There are billions of tiny air molecules, vast ocean currents, solar radiation, geographical features. All these things interact. Our computer models try to predict it, but they're never perfect because they can't possibly account for every single tiny variable. They can't measure the flap of every butterfly's wings, which, as the saying goes, could theoretically affect the weather weeks later. So, the unpredictability of weather, in this view, comes from our ignorance, not from the weather itself making truly random decisions. This deterministic view of the universe is very appealing. It suggests a universe that makes sense, that follows rules, that isn't just chaos. It means there's a reason for everything, even if we don't know what it is. It gives us a sense of order. But then, the 20th century came along, and with it, quantum mechanics. And quantum mechanics messed everything up in a really fundamental way. Quantum mechanics is the science of the very, very small atoms, electrons, photons, all the tiny bits that make up everything. And when scientists started looking at these tiny particles, they found that they don't behave like miniature billiard balls. They behave in ways that defy our common sense, and most importantly for our question, they seem to introduce true randomness into the universe. One of the biggest ideas in quantum mechanics is that particles don't always have a definite state until you measure them. Before you look, an electron might be in many places at once, or spinning both clockwise and counterclockwise at the same time. This is called superposition. It's like that coin flip again. But this time, the coin isn't just spinning, it's genuinely neither heads nor tails until it lands. And the act of it landing, or in quantum terms, the act of you measuring it forces it to pick one state. Here's the kicker: quantum mechanics says that which state it picks is inherently random. Not just, we don't know, but genuinely, fundamentally, without any hidden cause, random. A classic example is radioactive decay. An unstable atomic nucleus might decay, meaning it spits out a particle and turns into a different element. This happens all the time in nature. We know the half-life of these elements, which means we know how long it takes for half of a sample of them to decay. But We cannot, even in principle, predict when a specific individual atom will decay. It could be in the next second or in a million years. There's no internal clock, no hidden mechanism that tells that atom now it's your turn. It seems to be a genuinely random event. Another example is quantum tunneling. Sometimes a tiny particle can pass through a barrier even if it doesn't have enough energy to go over it. Imagine throwing a tennis ball at a wall, and it just pops up on the other side without breaking the wall. That's what quantum tunneling is like. And the exact moment or reason why it tunnels, or if it tunnels at all, is again, according to quantum mechanics, random. Scientists like Werner Heisenberg came up with the uncertainty principle. It says that you can't perfectly know certain pairs of things about a particle at the same time. For example, you can't know both its exact position and its exact momentum. The more precisely you know one, the less precisely you can know the other. It's not about our instruments being too clumsy. It's a fundamental property of reality itself. It's not that the particle has an exact position and momentum, and we just can't measure them both. It's that it doesn't have both simultaneously in a well-defined way. For a while, some smart people, including Albert Einstein, didn't like this idea of true randomness. Einstein famously said, "God does not play dice with the universe." He believed there had to be some hidden variables, some deeper unknown rules or properties that, if we could discover them, would restore determinism. If we knew these hidden variables, we could then predict the quantum events, but experiments, especially those related to Bell's theorem, have strongly suggested that these local hidden variables don't exist. The universe at its most fundamental level truly does seem to be indeterminate, meaning it's not fully predictable even in principle. It has an element of genuine chance. So, if quantum mechanics is right and it's one of the most successful scientific theories ever, predicting things with incredible accuracy, then true randomness absolutely exists. It's not just our ignorance, it's a built-in feature of reality at the smallest scales. Now, this leads to another question. If randomness exists at the tiny quantum level, does it matter for our everyday world? Does a dice roll or a lightning strike involve true randomness, or is it still just super complex determinism? Most of the things we see in our daily lives, like a ball falling or a car moving, are governed by classical physics, which is deterministic. The quantum effects are usually so tiny that they average out or get drowned out by the bigger classical forces. But there are places where quantum randomness might bubble up to the macroscopic world. For instance, biological mutations. These are changes in our DNA. Some of these mutations are caused by random quantum events, like a particle hitting a DNA strand in just the right way. These mutations drive evolution. If these were all perfectly predictable, evolution might look very different. So, here, true randomness at the quantum level seems to have a real impact on something as big as life itself. Another area is chaos theory. This is where things get really interesting, and it sits somewhat between determinism and true randomness. Chaos theory deals with systems that are completely deterministic, meaning there's no quantum randomness involved, but they are so incredibly sensitive to their initial conditions that they become practically unpredictable. Think of that butterfly effect again. A tiny change in one part of a chaotic system can lead to massive, unpredictable differences later on. The weather is a classic chaotic system. If you change one tiny input in a weather model, say, a fraction of a degree in temperature in one small area of the long-term forecast can completely change. This isn't because the weather is truly random. It's because our measurements are never perfect, and even the tiniest imperfection gets amplified over time, making long-term prediction impossible. So, for chaotic systems like the weather or the stock market, the unpredictability we experience comes from our inability to measure initial conditions with infinite precision and the system's inherent tendency to magnify those tiny errors. It's not quantum randomness, but it feels just as unpredictable to us. It's a form of practical unpredictability born from determinism's complexity. This means we have two sources for what we call randomness. One, epistemic randomness. This is when something seems random because we don't have enough information or our knowledge is incomplete. Like the coin flip or the weather in the classical view, if we knew everything, we could predict it. This is randomness as ignorance. Two, ontological randomness. This is true. Fundamental randomness that exists even if we had all the information possible. Like radioactive decay in quantum mechanics. There's no hidden cause, it just happens without a specific prior determinant. This is randomness as an inherent part of reality, and our human experience of randomness is a mix of both. When your car breaks down unexpectedly, it probably feels random, but it's almost certainly a deterministic process. A part failed because of wear and tear, manufacturing defects, heat, stress, a long chain of cause and effect that we couldn't possibly track. Our ignorance makes it random for us. When someone wins the lottery, it feels random. and the drawing of the balls itself is designed to be as close to epistemically random as possible. Air currents, machine design, ball weight, all carefully controlled to prevent predictability. Whether there's a quantum random event involved in the exact trajectory of a specific ball might be technically true, but practically, it's about the overwhelming complexity and our lack of perfect knowledge. The practical impact of this distinction is huge. For scientists, understanding if something is truly random or just incredibly complex helps them build better models. If something is truly random, you can only talk about probabilities. If it's deterministic but chaotic, you can try to refine your measurements and models, but you'll always hit a wall of practical unpredictability. For us everyday people, it shapes how we see the world. If everything is truly predetermined, does that mean we have no free will? Are our choices just the inevitable outcome of prior causes, stretching back to the Big Bang? It's a heavy thought. If there's true randomness, does that give us space for free will? Not necessarily. A random choice isn't the same as a free choice. A free choice implies some agency, some conscious decision, not just a roll of the dice in your brain. But it does mean that the future isn't completely written. If the universe has a truly random component, then even with infinite knowledge, you couldn't precisely predict everything that will happen. Well, there's always that element of chance built into the fabric of existence. This journey through determinism, quantum mechanics, and chaos theory shows us a universe that's far more nuanced than simple cause and effect. It's not a clear-cut yes or no to the question of true randomness. At the very biggest scale in the everyday world, most of what we call random is likely just our ignorance about incredibly complex deterministic systems. The coin flip, the weather, the traffic jam, these are practically unpredictable, but in theory, if you knew every single detail, you could figure them out. They are deterministic but chaotic, or simply too complex for us to fully grasp. They are random because we are ignorant. But at the very smallest scale, the quantum realm, the evidence points strongly to true ontological randomness. Particles seem to make choices, to be in states that are genuinely indeterminate until observed, and the outcomes are fundamentally probabilistic. It's not that we don't know the cause, it's that there is no predetermined cause for that specific outcome. It is truly random. So, the universe seems to be a strange mix, a mostly deterministic but often chaotic and practically unpredictable macroscopic world sitting on top of a fundamentally probabilistic and truly random quantum foundation. This means that when you say something is random, you might be pointing to very different things. Sometimes you're admitting you don't know enough. Other times, you might be bumping up against a fundamental aspect of reality itself. And that's a pretty wild thought, isn't it? To think that even with all the science and all the knowledge we could ever gather, there's still a part of the universe that just operates on chance, on a roll of nature's quantum dice. It makes the world a little less predictable, a little more mysterious, and in some ways maybe even a little more alive. We live in a world where things happen that even a godlike demon couldn't predict, because some things just don't have a pre-written path. And that's not because of ignorance, it's just how things are.